What is my response? Cigarette, right? Cigarettes, number of cigarette. Cigarette. Oh. And then my explanatory. Runners, right? Runners. Right? The number of people who regularly run for exercise. We just call it runners for short. Okay, so I want to know, I'm going to have a cigarette. My equation will be cigarette. This is Y, this is X. I would say Y hat. Cigarette equal, well, equal, I'm going to say A here plus B. Don't write it down. We're going to replace A and B later. Times what? Times the runner. That's my X. Right. B is 0.178. What is A? 48, right? Because nobody run, right? Nobody ran means zero runner, right? So when remember what is it? The y intercept is estimate y hat when x equals 0, right? So 48. And that's it. That's your regression. Equation. 48. Not just 48. Later when yeah, let's write like that. Do you have any questions so far? Just about anything that you kind of have a little confused? So it's important that you know which one it is. Yeah. Oh, decrease. Yeah, thank you. Thank you very much. It's decrease. So negative. Maybe I'll put it right here. Oops. Thank you very much. Negative. Like that. Right. Or you can replace the plus with the minus. Maybe I'll clean it up a little bit. Thank you very much. Like that. Let's say decrease. Negative. So it's important that you know what is. I think the most important things so far is you know what respond. What is the explanatory? You don't want to have it backward. All right. Example number 2. We'll do together. Shrinking forest. Scientists measure the annual forest loss in square kilometer. Square kilometer. In Indonesia, from 2000 to 2012. I'm going to just say 2000 is from 0 to 2. They found the regression line to be forest equal 7,500 plus 1,021 times the number of years. I'm just gonna 2000 is start at 0. Right? 2011, 2001 is 1, etc. For predicting forest loss in square kilometer for years in 2000, what is the slope of this line? Slope will be. What's my slope? Yeah, whatever next to the x, right? 1021. Say in word what the numerical value of the slope tell you. So this one they ask you to interpret it as slope. So you go back to the very first slide. First slide or second slide? The first slide. Right here. How much do we expect our y variable to change on average for every increase in our variable x? So if I would have interpreted this. So I'm going to write interpretation. of slope. So we expect, remember the expect change in y, we expect change in y forest loss to change how much? About 1021 square kilometer on average. On average. So the change in y, let's see what it say. I'm gonna do this. The expect y variable to change, which is how much? 1021 on average for every increase in our x variable, for every what? For every year, right? Or per year or for every year. Or every 1 unit. 1 unit here is 1 year. You say per year for every year, doesn't matter. I'll say per year. Sound better. So this is, ooh, too big. My y, expect y to change on average for every unit increase in x. Same thing I said in the first slide. So far so good. You still have to remember the generic interpretation. Okay, so the next question is kind of math-ish. If we measure the forest in meters square per year, what would the slope be? Know that 1 million square meter in a square kilometer. So this is the mean. This mean is 1 square kilometer equal to 1 million meters square meter. Okay. If we measure in square meters, what the slope would be? Remember, slope is in square kilometer is 1021. That'll be 1021 times 10 to the 6. That's your new slope. New slope. And what does that mean? What does that mean? That mean a loss of 1 billion now, right? 1 billion. If you move another, so this can be 1.021 times 10 to the third, right? 10 to the third, 10 to the 6, 10 to the 9, that's billion. So a loss of 1 billion. What did I say? Square meter. Per year on average. Or on average per year, doesn't matter. I'll keep it on average per year. Why don't you guys do number 3 and put in the chat? Before you do number 3, let me say something. If I ask you to round your answer in, say, 4 decimal places, will be what? 1 over 10,000 places, right? So thousands of places, 10,000 of places. Okay, that's all I want to say. I showed you the hidden message last time, right? Maybe I'll put up something else. Understand that these kind of classes could be very wearisome. Sometimes I try to lighten up the mood by showing you stuff. Let's look at something. Oh, good God. All right. What you got? Oh, I can check it out here. Only 2 chats? The rest of you. Oh, yeah. Stephanie, good job. Yeah, thousands of square kilometer. I mean, 10, so B equal 10, 21 divided by 1,000, right? Which is 1.021. So roughly 1,000, roughly a bit more than 1,000. I don't want to write down the loss of a bit more than 1,000 square kilometer per unit on average. Okay. All right, let's predict the forest loss. We have the equation, we can predict things, right? That's what we do. That's all the lecture about. The goal is to predict things. So some people will say that statistic is the best fortune teller ball you ever have. We can predict stuff based on science, right? Based on math. Of course, the prediction is all probability. It's not always true, but well, the chance of you getting that is much, much better than some random fortune teller. I don't know. Or maybe you guys believe in that. I don't want to offend you. Okay, so predict the forest loss in square kilometer in 2022. So we say that 2000 is year 0, right? So 2022, this imply what? Yeah, 22 year from 2000. So that means X is 22, right? So let me write out that equation. I'm not gonna write forest. I'm just gonna write Y cat equals 7,500 plus 1021 times X. I feel like writing that word down. Okay, so all you have to do is just plug in 22 for X to see what happened of the forest loss in 2022, right? So 7,500 plus 1021 times 22. What you guys got? It's a slow 4. Yeah. And 187,000. Yes, it's okay. 187, 462. Thank you, Kyle. Wow. Don't forget your unit, square kilometer. Please. The thing is, the relationship is positive, right? It's positive slope. All right. Let me entertain you a little bit. It's a long lecture. I want to show you maybe some picture. Maybe I showed you before. I don't remember. For a second, I log into Zoom. Oh. Okay, let me check. Let me double check. Okay, 7,500 plus 1021 times 22. Yeah, I got different. That's all right. Thank you both. Glad you double check. That means you're paying attention. 29,962. Okay. All right. Thank you both. Oh, sorry. I'm sorry. Let me share my screen. So you guys get the joke. I don't know how far you are. Why Bob Sponge not coming up? Oh, they're not coming up. There are a bunch of us. They're not coming up. Oh, you guys see this empirical rule? Right, this is what I'm talking about. Your extra credit number 2, right? See what you learn. Amount of burger mark 8. Confidence level. When mark 8, let me make it bigger. When Mark eats 68 burgers, a 60% confidence level. What is this? Oh, the orange shaded area show how full it is. Oh. When you eat 95 burgers, 95% confidence. Orange and green shade the area how full it is. And then when Mark eats 99 burgers, it's 99% confidence level. Orange, green, and blue show how full it is. Right, so it's kind of fun. I like it. A little bit of a joke in there. And knowledge too, right? Let's see, how come it's not done? See if it. I don't know why it does that. Star Wars. Whatever screen. Oh, right here. Well, you don't know what chi-square test yet. You know t-test, z-test, right? Just different kind of test. Fact check. So this letter, see a student write. Oh, I already showed you this, right? The nick. Here, the normal curve wrap. You can wrap that. That's pretty impressive. I wouldn't be able to do that. All right, that's it. Right, so let's give you an idea of what you do on your extra credit number 2. We'll show some more later. Let's continue in about 15 minutes and we have a break, okay? I believe in break. If I teach 2 hours, I'll give you 1 break. If I teach 3 hours, I'll give you 2 breaks. I don't like professors to teach and teach and teach. is tiresome. I understand they have to finish all, but it's just. All right, so let's finish 15 more minutes and we'll take a little break. Okay, so now how do you come up with that equation? Right? The question is how you come up with A and B, Right? So next we're gonna talk about the least square regression line, right? If I give you a data set, say I give everybody a data set, this data set, Stephanie and I ask you guys, I want you to draw a line that best fit this data set. A line that you think that is the best line there is. So say Stephanie say, I'm just gonna make up something, Stephanie. Well, for me, it looked like this, right? And then Tyler like, no, I like different. No, it's different. It's supposed to be like maybe like this, right? And then Max would be like, no, I like different one. Maybe like this, right? So and then other people say, different people have different lines. So which one is the best line, right? Well, in order to do that, we have formula to do so. So I'm gonna say hypothetically, I'm gonna have a line like this. Just hypothetic, okay. And before I define that blue line, I want to say the little black dots right there. You see, that's your observed y. Right, that's your observed y. Observe y, and this denote y, right? It's denote just y. And then all the point on the blue line, that's your predicted y. That's a little y hat, the equation, right? That's a y hat. So this right here. And what is the notation for predicted y? I just said it. Y hat, right? Y hat. Y hat. Okay, so hypothetically, I say this is my best line. Now, the best line say, let me make it a little bit better. I don't want it to touch the. Now, the definition of the best fit line is that when you draw a distance from the observed y to the predict y. So if I draw a little line here, these are error, right? These are error. Another name for error is residual, which we're going to talk about later. Residual. You have to wear the line in such a way that the distance between the observed y and the predicted y is the smallest. Because it has to be smallest because when I draw a square, say I draw a square, and I'm gonna sum up all these squares, the area of these squares. The sum of the square of the observed error has to be the least, has to be the smallest, right? So that is the best line. Usually computer do this for you. So let me say something here. The observed errors will be the observed y minus the predicted y. I mean, so this means y minus y hat, really? Right. Y minus y hat. Right. I'll call the residual. We come back to this. Don't worry, I'll come back to this. So again, a best fit line is you want to draw a line in such a way that the sum of all squares of the observed error is the smallest. Right? Hence the name least square. Literally, they talk about little square. Least square, a visual line. Right. Now, the line it does this is called, I believe, regression, I think. Least square regression line. That's where the name comes from. Of course, there's a lot of math behind it. You are not responsible for it. Now, so in order to calculate such line, such equation, you need a few things. You need X bar, unique Y bar, unique the deviation of X and deviation of Y, and the correlation R, right? For B, which is the slope, right? Remember, this is the slope. Is calculated as R times, I think, SY divided by SX. So the correlation R, the coefficient correlation R times the standard deviation of Y divided by standard deviation of X. I show you how to calculate this in Google Sheet. I'll show you how to do it in calculator because we need for the exam. For A is gonna be equal to. Let me make it a little higher for now room. It's gonna be equal to Y bar, the sample mean of the Y column, minus the slope times the sample mean of the X column. And the equation is Y hat equal A plus BX. So to estimate the regression line, to construct this, you need 5 statistics. On the final exam, you will use calculator to come up with these. Okay? I'll show you how to do it. And you can check your result too. If it's up to me, I would let you use Google Sheet. It's much easier, but it's not up to me. So. Okay, so let's take a look at this example. The example is easy. I give you everything. I give you all 5 of those. All I ask you to do is calculate these for me. Go ahead and calculate the slope B and then the intercept A and put in the chat for me. Let me remind you the formula. I'm sure you got the same answer as I do. So. uh, four, like the problem say, four. And let's see what I can. Remember the example, the rent price and apartment size we did last time? Minus. Instead of give me how about this? Instead of give me the slope estimate and the y-intercept estimate, give me the estimate regression line, so that I know that you know how to write that. In your answer, give me this. By the way, when you hear the word estimated or predicted, you want to use y hat. Let me see. All right, let's see. So Tyler got it right. Carly. Yeah. Yeah, Stephanie. Tyler. Yep. Probably say white hat as well. Okay. Yeah. That's it. Like white hat. So white hat. Oh, let me write all these out. The formula is in black. 0.82 times 204.8246 divided by 202.2837, and I got roughly 0.8303. Went around to 4 decimal places. So that's my B. And then for A is Y. So Y bar is 1070.625 minus B is 0.8303. And then time X bar, which is 1015. And I got 227.8705. And then my regression line is Y hat. If you want to say Y hat in this case will be what? Y hat in this case will be. Remember the example, it will be the price, rent price, right? The rent. And your X will be your apartment size. Predict the monthly rent for a renter whose apartment size is 970 square feet. All you have to do, plug it in, right? 227.8705 plus 0.8303. What you got have? You have it already? You don't? That's okay. Oops, done. Okay, I got 1,000, routed to nearest cent. I mean, 2 decimal place, nearest cent. $1,033.26. Don't forget your units, dollar. Right? So far, so good. Okay, so this is easy. Right? I just want you to practice this. So 2. Now, oh, let me take a. We're gonna take a break here. I promise you, I'm taking a break. Let's take a break. We'll come back. Mm-hmm. 2.
answers, but whenever I try to knit it,
Oh,
it'll give me an error.
Oh, because maybe you put the.
Well, I
see.
downloaded it because I could get it to knit here, but as soon as I did like the histogram
Oh,
and summary, then it
let's
wouldn't
see.
let me knit.
Type E1 not found.
I imported it.
Yeah, but you have to say you imported, so that you have to put it in.
Okay.
So let me do a library. Re-Excel. You have to have this. Maybe you don't have to do that. I'll show you. Is that it?
Yeah.
Renamed it. It doesn't like space.
I did underscores.
Oh, you did. Okay, that's it.
Oh, no. Okay. It showed it.
Oh. Oh, okay, that's fine. I think it's put in the score for you.
Okay.
Yeah, that's how you. That's not like space. Yeah, there you go. And if you go to so here you see the library read it.
Yeah.
If you don't have that before, you're gonna copy all of this. I don't need that anymore. I already had it there. Don't copy the view. You don't need the view. Go back to where is it? Good for you. I'm proud of you. Who's this? Okay, what I'm gonna do next is I'm gonna go to File, set worker directory. This is your thing, right?
Yeah.
Okay. What I'm gonna do more. So I always know that it has to come here.
Okay.
Yeah, sometimes. Yeah. So right here, you see it in your console. Copy this. Don't copy the little arrow. It won't read the thing. Right there.
Hi, sorry.
Yeah. Okay, now there you go.
That's a little better. So.
Yeah. Call. Let's see. Ooh. It is. Typing speed.
Yeah. Or LL.
Ooh, ooh. Oh, is it okay? Is it,
Yeah.
Okay. Summary. Good. Mhm. Let's see everything. Very good. Very good for you.
I just went on because I
Very good.
couldn't
I'm
get
very
it to
proud of
knit.
you. Yeah, now.
Okay, now it'll-
Yeah.
good.
Very,
So
very
this
good.
is
I'm
that
so
first
proud of
part.
you. Oh, by the way, one more thing. When can you copy all the answer the question for me when you're done?
Yes.
And then answer it.
Yes.
Yeah.
Do you want me to just like put this into, because these are the questions.
Yeah.
As
So like
answer.
copy. For example, task. Well, that's your answer.
No. That was already.
Oh, okay. Is why funny?
When
Oh,
I
you do
had
it for you. Oh,
When I did it in the Word, I had to
Oh.
convert it from a PDF to a Word so I could actually edit.
you can do it in here.
Okay.
Yeah. I'll show you. Very easy. You don't have to download it. Oh, forgot. Oh, I might have a little thing.
That's okay. That's okay.
So proud.
Not super hard. I just
Yeah.
couldn't get it to knit. Other
Yeah.
than
Yeah. If you guys have problem with knitting, if you do your extra credit in R and you have problem, I can help you. Okay. I'm helping her right now. Oops.
I had no clue. It's been
Okay. It's just doing like that. Bigger. So for example, to is right. Okay. My dark so I have to do that. Where's your typing? No. Right here. Okay. Is so you can do like that. What? It's new, right? It's new. Okay.
yeah.
So new.
so I don't have
It
to
doesn't
put it
matter.
in the like 3 little ticks because you're just trying to put.
I'm trying to make it, how come it doesn't, it's not bolded? Usually if you do like, say, you do bold it, because I think they put the dollar sign. See, bold it, yeah. It is difficult for me. Text. Well, you don't. If you want to text, if you want to write something long, you need to have the text.
Okay.
Text. I'm just gonna put examples. Okay. Okay. Some text. Now, if you want something else, so up to you, right? Or I'll show you another. So there.
Okay.
This is also another view. I'll show you a different one. No, 3 different ways.
Okay. Awesome. I'll keep that in there so I know. Thank you so
Yeah.
much.
No problem. All right. Oh, so on the Thursday, is it Thursday? Yeah, so if you say, Mimi, I want to know what the grade for my final so I can get a B for this class, then I'll tell you. Yeah, but you have to come to see me. I cannot tell by email. Yeah. But you have to come anyway. It's a Kahoot. Okay, all right. Let's get started again, and then we'll have a little break in between, like just. Oh, I've been recording, which I don't have. I didn't have to. It's not sharing. It's not sharing. Oh, I forgot. Similar to what I showed you last time. Oh, you're gonna have a multiple choice section, and then a short answer question. I forgot. I forgot. I gotta take a look at it, but it's not long. Consider 3 hours or something. I think it's easier than my exam. The way they write it. Okay, so let's go ahead and do the coral reefs using calculator, because this problem right here is similar to your one of the final question I saw on the final exam, which I'm going to show you how to do in calculator. So the coral reef data set, right? The responder variable is my flow rate, right? Then the predictor will be the sea surface temperature. Okay, number one, say use a calculator to find the mean and the standard deviation of both variable x and variable y, and the correlation y between x and y. You know how to do this on Google Sheet, right? Just help you to do things homework. And then use the basic measure to find the equation of the least square line, which is what we did before. That's what they meant. Use the basic measure and use those formula up there. Question number 2 is asked you to enter the data in the software or calculator. In this case, I have to show you in calculator so that you know how to do it on the exam. And to see if it match your regression line, it match with the number 1. I'm gonna do number 2 first. Okay, I'm gonna do number 2 first. So if you take out your calculator, I wonder if this will show. I wonder if it will show. Let me check. Okay, let me see. What advanced on your calculator, is it recording? Really? Let me see. Wow, that's really.
Yeah, it is.
It is okay. All right, I'll believe you. Okay, that's on you. Okay, very good. All right. All right. So on your calculator, on clean. Let me see. Let's see. I got the. I'm not sure. Can you see? Oh, you cannot see what I'm. Right there. They're like that. Okay, I'll do like this so you can see. Okay. You wanna go to stat, and then edit there. Press enter. I already have my data set here. If you don't, you should have it. You should enter the data in the slide. Pull up the slide, enter it in. So the X first and then the Y. If you have something already in there, says, I'm gonna use L3 to make an example, okay? Oh, stat right here. So stat, and then number 1, edit, press enter. The step on the slides. If you want to delete a column, just put the cursor over that column, that line, say L3. I don't want to delete L1 and L2. That's my data set. I'm going to demonstrate with L3. Just put the cursor there and then press clear. Oh, how come it's not clear then? Oh, there, it's clear for me. Clear and enter. Right, go ahead and enter those L1 and L2. If you have questions, please let me know. You need to know this. It's on your final exam. Okay. God, my hand's so yellow. It's like the hepatitis B. Let me call it the light. It's not as yellow as here. Got it? Everybody got it? Okay, all right. All right, now we're gonna quit. Go back to stat again. Go over calc and go to number 8. Down to number 8. See that linear regression, A plus BX. Press enter and then enter again. There you go. I'm gonna write down. I'm gonna write down on my slide. You don't have to. So y hat equal 5.0389. I'm gonna route to 4 decimal places. Minus, plus, minus, so become minus, right? Minus 0.1579 x. Make sure you write down your R value as well. R value is, was it negative? Yeah, negative 0.8111. Okay, all right. All right, so that's the one shot, right? On the exam, I don't know how much they want you to show work, but I'm gonna show you both. So this is for you to know that's your answer is. Now for the longer process, the process that I show you how to use the formula, we're gonna go back again. Go back to stat. Yes, go back to stat. Right. Go over calc. You see 1 bar stats, number 1. Click press enter. And then I'm gonna want L1. How do you get L1? You see L1 right there. So second one get you L1. Second one gives you L1. And then it tell me all the statistics of my C surface temperature column, right? The X column. I'm gonna write down. I need what? I need X bar, right? I only need 5 statistics. So I'm gonna go write down X bar. X bar equal 26.4667. Now standard deviation, should I take sigma X or SX? There are 2 of them here. You want SX, right? You want SX. So S of X is 0.2251. I route it to 4 decimal places. So far, so good. Now, by default, even if you don't put L1 there, your calculator would always put the statistic for L1, right? So quit again. Go back to stat again. Go to calc. Again, 1 bar stat, same thing. Now I want L2. So second number 2 give you L2. Okay, I know it say X bar, but that's actually your Y bar, right? So Y bar is 0.86, and then S of Y is 0.0438. So far, so good. You have any question? Let me know. Hmm? There's no. No, it show on the first one. It show on the.
Oh, yeah, it doesn't show.
Oh, really?
Yeah.
I got the old one to show. Let me see. So I gotta figure it out. I know this calculator is showing me R. Okay, I gotta figure. Let me see. Stat, calc, number 4. My show. Oh, you can't see. My show R. Let me see, Vic. You can calculate R here. I have no idea. Mine always have R, so I have no idea. Let me see how to. Press second, press number 0, catalog screen. All right, second 0, catalog. And then diagnostic on. Oh, good God, DD. Diagnostic on. Okay. Press enter, one more. Done. Okay. You guys got all that stuff? Yeah.
Okay.
Oh, okay, yeah. Cause I think but I turned it on. All right, and leave it like that for the rest of your life. All right. Oh, let's calculate. Let's calculate the one in blue. So I think on the final they want how you do in blue. So I need what? I need B is equal R times SY divided by SX, right? All you have to do is plug it in. R is negative 0.8111. SY is 0.0438 divided by SX is 0.2251. Oh, I can do my calculator for that. Divided by 0.225. Check with me, you gotta. I got negative 0.1578, right? And then A is Y bar minus B times X bar. Y bar is 0.86 minus B is negative 0.1578 times X bar is 26.4667. Minus, so plus 0.1578 times 26.4667. I got 5.0364. What do you think? It's the same we have, right? The same thing we have, right? So A, so B. So you can check your answer. You can check your answer. Do you have any questions? Saying what the numerical value of slope tell you. Okay, somebody tell me what is the slope interpretation here. Remember, we expect change, we expect, right? We expect change in Y value. So change in growth rate of coral. To be what? To be what? To be the slope to be 0.1579 on average for every unit increase or decrease in X. For every what? For every unit, for every Celsius, how do I spell Celsius now? For every temperature, the temperature. Celsius increase in seawater temperature. For every unit increase in X, right? To think about it, right? As the water get warmer, the coral is dying, right? So that's what I'm saying. The growth rate is decreased. We see the negative relationship, right? Negative R right there, negative relationship. Bleach. I think that's what they call in biology. Do you have any questions so far? So far, so good. Okay, so on your exam, you can have something just like this. It's kind of like the coral reef problem. And I believe that I don't know what they want. On the answer key, I see they calculate all of these out. So I guess they want to show work. But I show you both. So whatever they want, you can do it. For the slide here, I just show you how to do the step number 2, but I did not put anything for step number 1. but it's in the video. Okay. All right. For 5.4, please read it yourself. Just read it. Read it. It could be on the exam. Just read it. I haven't taken a look at the exam closely. This weekend, I'm planning to write your practice exam. But read 5.4. I don't want to reread it for you. Okay. Now, let me see what do I have here. All right. Let's do the slide about R square, and then take a little break. Oh, not break. All right. Coefficient of determination. What's R called? What is R called? R called. What's the name of R? Correlation, right? So don't mix up between the two. They're very similar, right? Coefficient of determination. If R is between -1 and 1, then R squared. If you square any number between -1 and 1, what you get? If you square any number between -1 and 1, what you have? And then you square it. Well, the positive number, the negative number square being positive, right? So the least, the smallest, the number you have will be, that's the largest. 0 to 1, right? 0 to 1. So R squared range from 0 to 1. What else range from 0 to 1? Do you remember what else range from 0 to 1? Probability, right? Probability, p-values. Okay, so this right here, the interpretation of, it's right here, the interpretation of R squared. And it will be on the final. Same thing with interpretation of slope of R squared. It say the percentage, or whatever the percentage, you square the R, then you will get the percentage. The percent of variation in R response Y that can be explained by the linear relationship. It's very important that you should have the word linear relationship. But if you don't have that, you might get the point. Right? What kind of relationship are you talking about? Is it linear or curve or sinusoidal? Right? Only linear relationship without explanatory variable x. So very generic, right? All you have to do is you replace the percentage, the number, whatever. If you get R, you can square it, and then you get R squared. And then you replace the response variable y in context. Same thing with the explanatory variable in context. That's it. Everything else stay the same. I'm not going to even bother to show you how to calculate R squared. It's in the book because you have the calculator to do that for you. Okay, all right. Let's do this one. Example. Why don't you guys give the answer in the chat for me, and maybe the interpretation too. Let's see how you. I highlight the one in blue is the one you change. Everything else stay the same. Sorry. Looking for a fun picture for you. Do you have any fun picture you want to share to me? I'll share it to class. Even your dog, your cat, or random picture you took. Oh, you should. I have some joke, very offensive. I don't want to show it to you. My professor, before he showed it to us, and I thought it's kind of offensive. I don't want to show it to you. It's fun. It's a good laugh, but it's All right, I got some for you. Yeah. Yes. I think we print it out for you because we don't want to check. Right on what? On the sheet? No, no, we bring it to you. That's why we don't want you to write on, but we provide it to you. Got some fun picture I want to show you. Let's see. After we done. Mm. All right, let's see what you guys have. Try to none. Oh, R square. Okay, thank you, Kyle. At least get the I square for me. You don't want to. How do you get that? Just square it, right? So R square always positive, or at least 0. R square equal negative 0.81 and then square. I got 0.6561. Okay, so the way we say this would be, maybe I'll put the answer here, interpretation down here. So same thing, right? So 65.61% of variation in Y value. Y here will be the growth rate, can be explained by the linear relationship with seawater temperature. See, very easy. The easiest one out there. No, Very easy. I literally copy everything you said, just put in the contacts. No, it took me a long time. Take the whole day yesterday just to make these slides. Behind the scene is a lot. So graph I make for you take a long code. All right. Let me entertain you again. So slow giggle. Share screen. Continue. Right, this one. You can say that to your friend. Yeah, it's if they get it, they probably don't have friends either. All right, how about this? Captain America. A little smaller. Will you reject the null hypothesis? P-value is 10%, right? It's bigger than alpha. So no, I don't think I will. Maybe one more. Maybe this one. I didn't think this one either. This is really significant other. All right. Okay, back to that. It helped. It helped. This line of the move. Okay. I used to do that a lot. I forgot this semester. Every now and then I just all right, residual. Let's see. I think we can finish this. It'll be quick. It'll be quick. We're gonna use Google Sheet. Okay, residual. Do you guys remember back up here? When I was explaining the least square regression, and I talk about the distance between the observed y and the predicted y. Where is it? Right here. Remember this picture? A little distant red here. That's your error, right? That's called residual. And you want it to be small, right? Error. You don't want error. So so come back here. I'll use the same one again. So think of this. This right here, that is all the variation of y. All the variation of y, right? And the y mean will be some number in the middle, right? You add up all the y value divided by the number of observation 1, 2, 3, 4, 5, right? So add up all the rent price divided by 5. I say my rent price is somewhere in between here. I don't know exactly what it is. I didn't calculate, but I know it's somewhere here. Oops. And that'll be my y bar. So y bar is somewhere around there. Now, pretend that I don't know any information about the regression line. I don't know the R, I don't know the standard deviation. If somebody asked me, Mimi, can you predict what is the next apartment price? Then my best bet is to use the average of y, right? It's my bet as sad people, I just do average y. So if you use that little average, a little blue line, see what happened. Now is your error from the observed. Remember the black that is your observed y to the predict y is large, right? But we can do better. We can do better. Now, if I have the regression, the best fit line, if I have the best fit line and I fit here, best fit line, say that in green, so now if you compare the little arrow in green and arrow in red, it get better, right? It gets smaller, right? So, so the residual is the difference between what is actually observed and what our regression equation predict. The residual is equal observed y minus predicted y, or better yet, y minus y hat. So if I ask you to calculate the residual, what do you have to do? If I ask you to find the residual, what do you need? Well, this will be given. It has to be. But you need this, right? You need to come up with the y hat. That's what we've been all doing all along. Okay, if you remember the rent price versus apartment size that we did earlier, we come up with the equation y hat. I just recopy this is the equation. And I asked you to find the residual for the fifth observation. Fifth. 1, 2, 3, 4, 5. So right here. The fifth observation. So your observed value will be the y, right? The y will be 995. So this implies my y is 995 and my x is 970 square feet, right? Okay, I want to find the residual. The residual is equal E equal y right there. I use E, but you don't have to. Okay, just I don't want to write residual. So y is 995. That's your observed y, that little dot thing, right? How do I find y hat? How do I come up with y hat? Looking at the equation, how do I come up with y hat? So I got y. Well, how do I come up with y hat? I'm just gonna rewrite residual so you're not confused. Residual. So someone tell me, how do I find y hat? You don't have to tell me the answer. Just come up with it. I plug it in. I plug in x, right? I plug it in there. So if I plug it in here, so y hat equal, I don't want to rewrite this. Right there. You plug in what? 970 in there. What you got? 227.8705 plus 0.8303 times 970 I got y hat is $1,033.26. So equal negative 38. The residual is negative 38. What does that mean? What does that mean? Is it 38.26? What does that mean? That mean it's below the green line. Maybe this point, the direction. It's a good point to stop. I'm gonna take attendance, and then we can go. We continue next time. We did a lot today. I'm really satisfied with it today. Oh, I forgot to show you how to do linear regression but give me a second. Okay, I'll show you real quick. Equal, so it's in the video. Minus, and then y, no y data, y, and then x, and then it say you want to calculate the slope. Yes, cosine 1, right? So say true. And then the next one, just put don't put anything. That's it. Right there. So you can remember this. So this is your slope. This is your y-intercept for the coral reef problem. Okay, help you do the homework faster. All right, so let's take attendance.